All right, in this video, we're going to be looking at application of exponential functions to some story problems. So let's review exponential growth and decay. So remember, exponential growth is when we have something in the form y equals a times b to the x power, but b is bigger than 1, then if b is bigger than 1, it's exponential growth. Now, when we deal with story problems, though, they're not going to talk like that and say, well, when b is 3.2. Instead, they're going to give us percentages, and so they're going to talk about, you'll hear phrases like a growth of 3.2% or a growth of 7.9%. And so they're going to be phrasing it a little bit differently. So we need to recognize that when they say that, that's not our value for b. We have to find out what b is. And so this is really important. So we're going to find b, we have to take 1 plus our value of r, which r represents your percent as a decimal, which we'll talk about this more in just a second. And that represents our equation then that we could create for exponential growth. And the same thing is true for decay. Remember again, decay is when b is between 0 and 1. Then it's going to decrease from left to right. It's going to decrease over time. So in that situation, to find our b value, if it's going to be a situation where they say the population is decreasing or it's losing value by a certain percentage, then we would take that percent, change it to a decimal, and subtract it from 1. So that's what I want to talk about next, is that value for r. You see that I have these two steps, so very similar to what I just talked about. In order to find our value for b, we're going to take and change our percent from a percent and change it to a decimal, and then we're going to either add it to 1 if it's exponential growth or subtract it from 1 if it's exponential decay. So 1 plus r or 1 minus r, depending on if it's exponential growth or decay. So let's look at our first example here. Oh, by the way, the other values, remember a represents, in this case, our starting amount, or the starting point, the initial amount. A of t refers to the amount after a certain amount of time periods. So that's what those formulas represent. So you really only need to recognize one formula. You just need to understand it's still a times b to the x power, but you just need to understand that to find b, if it's growth, that means it's increasing, so we would take 1 plus r. If it's decreasing, it would be 1 minus r. So let's look at some story problems here. So it says the population of a large city was about 4.6 million in the year 2010 and grew at a rate of 1.3% after that. What exponential function models the population of the city X years after the year 2010? All right, so 4.6 million is their starting amount. So that's what we're basing it on. So in the year 2010, the population was 4.6 million. Now we're not going to write that as actual millions, so we're not going to do a ton of zeros. We would just say A represents 4.6, knowing that when we get an answer that it's in terms of millions. All right, now it says that it's growing at a rate of 1.3%. So the rate as a decimal, so to change a percent to a decimal, remember you move the decimal to the left 2 places or divide by 100. And so 1.3% would be 0.013. So to find our B value, since we're growing, we would take 1 plus 0.013, which is 1.013. So our equation would be our initial amount, our A value is 4.6, times our B value, which is 1.013, to the x power. So x is your exponent here. If you want to use t for time, that's fine too. According to the model, what will the population be in 2040? So you got to be careful. We got to figure out, what does x represent? Well, x represents the years after 2010. So 2040 is 30 years after 2010, so x would equal 30. So to find our total amount, we would take 4.6 times 1.013 to the 30th power. And you can just do that on your calculator, and you do that on your calculator, you get 6.8. That means it's 6.8 million people is what we'd expect the population to be in the year 2040. All right. Let's look at this next one. So this next one, they give us the equation. And so from that equation, we're going to be pulling out some different information here. So it says a factory purchased a 3D printer in 2010. The value of the printer is modeled by the function f of x equals 30 times 0.93 to the x power, where x is the number of years since the year 2010 again. What was the initial value of the printer? So remember, A represents our initial amount. So we can easily see that, well, the initial amount is 30. So the initial value of the printer would be $30. What is the value of the printer after 10 years? Well, we would just put 10 in for X. When you do that, you get $14.50. All right, so it says, does a printer lose more of its value in the first 10 years or the second 10 years of its purchase? All right, so we just found that after 10 years that the value of the printer would be $14.50. Okay, so in the first 10 years, it basically lost. It went from being valued at $30 when it was purchased to being $14.50. So it lost almost half its value, or a little over half its value, in the first 10 years. Well, I wonder what that would mean in the next 10 years. So let's figure out what the value of the printer would be in 10 years later. It'd be 20 years from 2010. Well, when you do that, you get approximately $7. So it loses more, so it only loses $7.50 in the second 10 years. So in the first 10 years, it loses $15.50. In the second 10 years, it loses only $7.50. So it loses more in the first 10 years than it does in the second 10 years. All right, let's look at this next one together, and then I'm going to have you guys do the last one on your own. It says a car was purchased for $24,000. The function y equals 24 times 0.8 to the x can be used to model the value of the car in thousands of dollars, x years after it was purchased. Does this function represent exponential decay? So is it exponential growth or decay? Well, we could see that since our b value is 0.8, we can see that it represents exponential decay. The reason why is because that is between 0 and 1. All right, now it says, what is the rate of decay for this function? In other words, we want to figure out what the percent rate would be. So let's think about that for a second. Remember, we know that b equals, when it's decay, 1 minus r. We know our b value right now is 0.8. Well, if I want to figure out what r is, there's a couple ways I could do this. I could subtract 1 from both sides. And if I do that, I would get negative 0.2. Well, I could multiply or divide both sides by negative 1 or just change both sides. And so we get our r value of 0.2. So what that means is that represents a 20% decay or decrease in value. So that's what the rate of decay would be 0.2. And what does it mean? It means that it's losing 20% each year. Or we could say a 20% decay. So graph the function on a reasonable domain. What do the y-intercept and asymptote represent? All right, so that we could do on our calculators. So let's just go ahead and I'll show you how to do that. So on your graphing calculators, we're just going to graph the original function, 24 times 0.8. There we go, 0.8 to the x power. So to do the x power, we're going to do our exponent button. And then remember, next to the alpha button, that's where we find x. And let's change, I don't know what my window settings are, so let's see. That looks okay. Maybe I might want to change my x minimum. Let's just do a standard window. So do negative 10 to positive 10. And everything else looks good. So let's look at the graph. And you can see that when I look at this graph, I can't see everything. Now remember, this is a story problem, so we're not going to have a negative value for x or a negative value for the value of the car. So let's change our window settings. So now we know that the y-intercept is 24. Okay, so I did this on purpose because I wanted us to see how to change this if the graph doesn't look right. So we know that the y maximum, we don't have to have negative 10 necessarily. Let's just do 0. There we go. And same with our y minimum. All right, so we know that for our y maximum, we need to go up to at least 24. So I'm going to go up a little bit higher. Let's do like 30. And for my x maximum, let's change this one to, let's just do 30. We'll change it from 10 to 30. There we go. All right, so let's see what the graph looks like now. All right, so now we get a much better graph, so we can see the y-intercept here, and we have a much better shape. Now, if you look back at our notes, Part D says, when will the value of the car be about $5,000? Okay, so we're going to need to use the graph, and we're going to add another equation on that graph to help us find this out. Now we got to remember though that the y-axis, this 24, is referring to a car that was purchased for $24,000. So the y-axis is in terms of thousands. So we want to look to see for what value of x would the y value be 5, and that would represent $5,000. So it's going to be hard to look at our graph and just get that. So let's go back to where it says y equals here, and let's put in a new equation. So we're going to put in a horizontal line for when y equals 5. So now we see that this point here is when y is 5. Now I want to figure out what is the exact value for x. So x, remember, is in terms of time. And so we can do this. If we have a hard time seeing what that point is, we can do second and then trace. If we do second, then trace, one of the options is to find where two lines intersect at. And again, remember, we did this a while back. So it's not going to give us the exact value. It's going to give us this cursor. We're going to set this cursor somewhere to the left of that intersection point. And then notice how right now it says first curve. And when I hit enter, it puts a new cursor on the other line. And so now we want to enclose, we want to make sure that we have one of those cursors to the left of the intersection and now one to the right of the intersection, and hit enter. It says guess down here. Now we're going to hit enter one more time, and now it puts it right on the intersection. So a little after 7 years is when the car would be worth $5,000. Let's go back to our notes and write that in. So we would say here that it would take about 7 years. All right. I want you guys to try this next one on your own. It's very similar to the ones that we've done previously. So I want you guys to try all three parts here. You're going to have to graph when you get down here for this one. When it says, in what year will the number of hawks reach 280? So that's just like we did in the previous one. You're going to need to do an equation for y equals 280, which matches what we have here. So you don't have to worry about changing that at all like we had to do with the 5,000. But you're going to do a horizontal line at y equals 280. Now, just a little hint. You are going to have to change your window settings, because think about where your initial value is going to be. So make sure that you consider that when you go to create your graph, because you will not see it at first if you leave the window settings the way they are. So go ahead, try this one on your own, hit play when you're ready to check your answer. All right, let's see how you did. You should have gotten that for this problem. Just by looking at the equation, we could see that the population should be increasing because our b value is bigger than 1. It's 1.05. And what is the rate of increase? So to find that percentage rate, or to rate as a decimal, I would accept either one. On Savas, you want to make sure that you check to see how they want you to write your answer. But remember, our formula would be 1 plus r would equal that value for b. And so I could solve that for r by subtracting 1 from both sides. So 1.05 minus 1 would give you 0.05. Or if you change it to percent, represents a 5% increase. And like I said, when you look at your graph, at first the graph, you need to change your window settings. So then that way the y-axis would go greater than 220. And the x-axis, for this one, you could have left it as going from negative 10 to 10 or from 0 to 10. It wouldn't matter. And then if you did a horizontal line at y equals 280 and find the intersection, you'd say it was approximately 5 years later. Technically, I think it was around 4.9, but you can round it up to about 5 years later. Or since we know that this was in 2016, 5 years later would be the year 2021. All right, so hopefully that makes sense to you, and good luck now as you work on your second part of 6-1 assignment.